Hi everyone, welcome to Chapter 1, Section 3. I'm splitting up this section into 2 different days because there's a lot to go over here. Lots of vocabulary words, lots of new things. So that's why I want to split it up. So for today, Day 1, Part 1 of 1.3, we're going to learn how to set up an experiment or a study. So today's section is titled Data Collection and Experimental Design because we're going to design stuff today. Okay. So first, we have to decide what type of study that we're going to do, because it's not necessarily an experiment every time, because there's a difference. So the first thing I want to define is an observational study. So an observational study has the word like observe in it. So that's kind of the key thing here in an observational study, is that a researcher can only observe or measure. So a researcher observes and measures characteristics of interest. So whatever habit or characteristic that you're studying, and they're trying to gather this information from a sample. So the main thing here in an observational study is the researcher is not allowed to try to influence the people. So really, they're just allowed to observe. You can't tell them anything or change their behavior. If you're hearing all this banging right now, it's my cat trying to get herself into the room by jumping onto the door. Okay, so that's an observational study. So for example, I have that researchers observed and recorded the mouthing behavior on non-food objects of children up to 3 years old. So whether they chewed on them, because up to 3, their teeth aren't all there quite yet maybe, and so they're trying to see and record these things, but you can't tell the kid, hey, try to chew on this. It's really just, what can the kid do? So you just look at it. Okay, so the next type of study that we can do is an experiment. And I think this is what you hear a lot about. So experiments, because in an observational study, you weren't allowed to influence anything. In an experiment, you have to influence something now. So in an experiment, that thing that you're influencing is called a treatment. So we're going to apply some type of treatment to our subjects. And then record their responses. So for my example, I said an experiment was performed in which diabetics took cinnamon extract daily, while a control group took none. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease, while the control group experienced no change. Okay, so in this example, the researcher is the one that's influencing these people by telling them or separating them first into 2 groups. So there's a control group. So hopefully you remember or hearing that before somewhere. A control group, they get nothing. It's trying to be the comparison group. Let's see what happens if these people do nothing different. But then this other group, the treatment group, we're going to give them this cinnamon extract. So these are the people that you're really influencing and forcing them to do something for this experiment. And that's what the difference between an observational study and an experiment is. In an experiment, you have to impose some sort of treatment. In an observational study, you're not allowed to change or impose that treatment. The next type of study is called a simulation. So a simulation, you're using a mathematical or physical model to reproduce the conditions of a situation or a process. So basically, think the most basic is car manufacturers, they'll use simulations with dummies, like car crash dummies, to try to see what the effect of a crash would be on their car and to the person within it. But obviously you can't use a real person because what if the real person gets hurt? And they can't do that. So that's why they use dummies. Another situation where this might happen would be something like, let's say I was answering a true-false question on a test. And I mean, I'm not actually taking the test, we're just trying to simulate it. So what I'm going to do is I'll flip a coin, and if the coin lands on heads, then we're going to pretend that means that I got the question right. And then if it lands on tails, then we're going to let that represent that I got the question wrong. So then I can like keep flipping the coin to see for like a 10 question test, what kind of score could I possibly get? But because I'm using the coin to kind of represent getting a question right or wrong, then that counts as a simulation because you're not actually taking the test, you're using something to represent it. So, okay, the last type of study that we could do is a survey. And a survey, I think, is what we're most familiar with. So you make a questionnaire, send it out to people, have people answer it. Yeah, nothing crazy about that one. So let's write down official definition. So surveys are usually used to gather opinions from people, and then surveys can be done in a whole bunch of ways. You can do it by like in-person interview, by phone, by mail, by internet is more common now because, you know, technology. But yeah, those are our 4 different studies that we're concentrating on for this class. And so now that we know what we can use, like what method we can use, now let's talk about the key elements of experimental design. So as we're designing an experiment, specifically an experiment, not just like the observational study and everything, these are the 4 things that we want to make sure we have in an experiment. So the first one is called control. So we talked a little bit about this earlier with a control group because we want to make sure that we have some sort of comparison method. So we want a group to be there so that we can compare them with whatever changes that we're influencing, or whatever behaviors we're influencing. So not only are we trying to use a control group to look for a comparison between what treatments we're doing, but we also want to be able to see if there's anything that'll affect our results of things that we weren't trying to measure to begin with. And that's called a confounding variable. So if you can't tell the difference between the effects of different factors on a variable, those count as confounding variables. So let me give you an example. A coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. So now business at the coffee shop increases, cool, great, but it cannot be determined whether it is because of the remodeling or of the new mall. So maybe the remodel, you know, really brightened up her coffee shop, but then we don't know if the increase in customers is because of that remodel and how good her place looks now, or because the new mall opened and now there's just more foot traffic. So that counts as a confounding variable. Next, as we're trying to have this sense of control within an experiment, we want to talk about placebos, because placebos are a really common way to make a control group. So if you've never heard of a placebo before, it's basically like really common in experiments for drugs and medications, that kind of stuff, because we want to test if people, you know, if the drug actually works on people. But if we need that control group, then that control group, we want to make sure that they are also taking something to make them think that like, oh, I'm also part of this experiment taking something. Because the placebo effect is where this group of people in the control group, they get this like fake pill basically. And so the people there think they're taking something, and so like because mentally they're like, oh yeah, I'm getting drugs for whatever ailment I have, then they'll be like, oh okay, then I must be getting better. So then they actually exhibit like progress or improvement in whatever condition it is. And so this is actually not a good thing, because you don't want that to happen. You don't want the placebo effect, because then it shows that your drug, like the people who actually take your drug, could have gotten better just by taking like a fake pill. So that's something to be aware of when you're setting up an experiment. So along the lines of the placebo effect, since we're going to be giving some people a fake drug and some people the real thing, we want to make sure that when we collect data that the subject doesn't know which one they got, so that this placebo effect doesn't actually happen. So blinding is when the subject doesn't know which treatment they got. Because in that, otherwise, if they knew they got the placebo, then they would also think, oh, I just got a fake drug, so nothing's going to happen. And that mentality might influence the results. And we don't want that either. So then after that, let's say, so if blinding is the subject doesn't know, double blind is when the subject doesn't know and the researcher doesn't know. And when I say researcher, it's not like the overall researcher. Somebody has to know what kind of drug they're getting. But let's say like you are the researcher, then if that's the case, you're going to have people working for you, collecting that data. So those people that you send out to like, to the subjects to test whether or not they, the drug is working, when they ask them, if it's like a pain medication, like, are you still hurting, whatever, do you still feel pain? So those people who are collecting the data and asking the questions, they won't be influenced either by knowing whether or not the subject got the placebo or not. So if everybody doesn't know except for the very top people, the boss, then that's called double blind. Okay, so that's the first key element of experimental design, the control. So we want to have that comparison method. We want to make sure these people, whether they're getting the treatment or not, that method for comparison, whether they get a placebo, would be affected to help us control for other effects. Okay, so the next key element of experimental design is called randomization. So randomization really affects how you're going to set up your experiment. So in randomization, there's a few different methods. So the first way is called completely randomized design. And randomization is really for like figuring out who's going to be in what treatment group, or what treatment they're going to get, so that for whatever subjects you're testing, whether it be people or objects, that we split them up correctly. So randomization, we're going to define it as the process of randomly selecting or assigning subjects to treatment groups. So in the first method, the completely randomized design, you're just going to use random selection to assign subjects to treatment groups. So for example, let's say I'm going to do an experiment where I have 3 different treatment groups. Let's say my drug is for, I don't know, we'll make it up, to make you really strong. And so my first treatment group is they're going to get the full dosage of my new drug, whatever it is. Full dosage. So this group, they're going to take however many pills is the full dosage. The next treatment group would be, they only take half the amount, half a dosage. And then my control group, they're going to take a placebo. So if this was a pill, they would get a fake pill, whatever. Okay, so if these are my 3 treatment groups, then I want to make sure, let's say I had like 100 people to work with. So if I had 100 people to work with, then I want to make sure they randomly get assigned into each of these 3 groups, because I don't want to have, like, for whatever reason, like all the girls end up in one group and all the boys end up in the other group or something like that. Or like somehow all the old people end up in one group and all the young people end up in another group or something like that. So because if that happened, then I would be introducing confounding variables, because then at that point I wouldn't know whether it was like the full dosage that actually affected my results or if it was like their age or something like that. So that's why we want to randomly assign. So when I do the random assignment, it could be something like a coin flip. Well, a coin flip, you don't really get 3 options from it. So maybe we roll a die. And then we could see like whatever number they land on, that would be which treatment group they end up in. Okay, so I'm just going to put a little star at the bottom. The whole point of this random assignment into groups is to eliminate or try to eliminate confounding variables. Okay, the next method is a randomized block design. So again, this whole point of randomization is to try to get rid of confounding variables. So a randomized block design is basically saying, like, we already know there's going to be a confounding variable, so I'm going to separate that out right away. So let's say I'm still using this like super strength drug, whatever. And in this example, I already know like boys tend to be stronger than girls just because the way that they're physically built. So if I know that's going to affect my results already, then I'm going to split them up first. I'm going to basically run 2 separate experiments, one for boys, one for girls, and then I don't have to deal with that whole like strength difference to begin with. So if I were to set up my experiment visually, it would look something like this. So let's say I am splitting my groups up into boys and girls. And then from there, I still have my 3 treatment groups. So then out of the boys, just out of the boys, I'm going to separate them into my full dosage group, my half dosage group, and my placebo group. And when I split the boys up like that, I also want to make sure I'm still doing that random assignment. So either flipping a coin, rolling a die, whatever, to make sure that the boys, out of the boys, they still randomly end up into one of the 3 treatment groups. Okay, and then I'm going to do the same thing for just the girls. So out of all the girls, I'm going to split them up into the 3 different treatment groups. Okay, then I get to, out of just the boys, figure out which drug did better, out of the girls, which drug did better, and so on. So that's randomized block design. So again, it's something you already know is going to affect your data. So that's what you have to separate out by first. Okay, the last type of design for randomization is called matched pairs design. And matched pairs is like the most specific one. So matched pairs, basically you're going to have similar pairs of subjects. And basically you kind of like pit them against each other. So matched pairs will only work if you only have 2 treatment groups, so either like full dosage and placebo or something like that. But matched pairs design, you want to choose these 2 subjects that are going to be really similar to each other. So a lot of times matched pairs designs are done with twins, because twins, like genetically, are very similar. And so that's why they make really good matched pairs design experimenters, or subjects for the experiments. Otherwise, you could also pair people based on a characteristic that's very similar. So if I took if we were doing this strength study or whatever, strength drug study, then I could find 2 people who were, work out exactly the same amount and like, have the same diet and blah, 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 whatever else. So if those 2 people were very similar, then it would be easier to compare with each other whether the drug was working or not. So once you have all your pairs, then each person in the pair gets a different treatment, and then you can compare them with each other. And obviously you're going to do this with more than just 1 pair of people. You're going to have a bunch of pairs that are all similar in different ways, hopefully, and they all get compared to each other like that. Okay, so then the third key element of experimental design is sample size. This one's simple. Just you want bigger sample sizes. Bigger samples are better. The reason why that is because let's say you have some people in your sample that are just like really strong or whatever, or really weak. I don't know, the extremes. If that happens, if you have a bigger sample, you kind of have more people to kind of even that out so that they don't stick out just as much, and it just makes your data a little bit more consistent. So that's what we want. And then the last key element of experimental design is replication. So replication means that you would be able to redo this experiment with different people and still come up with similar results, because that really proves that like your experiment worked and that it was designed well. Okay, and so those are the 4 key elements of experimental design. We got control, randomization, sample size, and replication. If you have those 4 things in an experiment, then you have a well-designed experiment. We're going to pause here for section 3 and continue the rest in part 2. Thanks for watching. Bye.